Hello! Did you install Klipper to get rid of this sort of mess? Great, we'll quickly go through a few calibrations to do exactly that. So, the main reason you want to calibrate your printer is first layer adhesion. This is why most people look into calibrating. You try to print a thing and then all you know is there's a spaghetti dinner on the build plate. The second reason would be print quality. Not just the first layer is directly affected by poor calibration, but all of them, which translates into shifted layers and various other glitches. The third reason is consistency. Having a calibrated printer ensures that no matter how many times you print something, it'll come out exactly the same each time. One of the best sources to guide you through calibration is Ellis's Print Tuning Guide, which you can find at ellis3dp.com. Ellis is responsible for a nice evolution in calibrating pressure advance. We'll get to that later, but this video will rely heavily, and by rely I mean follow, the guide on Ellis's website, a link which you can find below in the description. If you like this type of content, feel free to like the video and subscribe to the channel. First things first, if you have some known issues, sort them out. In my case, I had some filament leak somehow on my hot end, so I'm going to clean that. As you can see, my ender has gone through a few updates that aim to increase the quality and reproducibility of my prints. Basically, I went for a magnetic bed, better springs, a new hot end alongside the direct drive bracket, and of course Klipper. Things like cleaning the hot end might not affect things much, but little things do add up, so better safe than sorry. After cleaning everything up as well as I can, I'll also change the nozzle with a fresh one. Apart from that, make sure that all of your screws are tight, bearings are fine and spinning freely, and your nozzle isn't clogged. It's best to start with a fresh one if you can. While we're here, we can start with the first calibration, that of the extruder. It already helps that we've disassembled the hot end because we don't want a nozzle for this step. What we are aiming for here is to find out and compensate the amount of filament we request to print versus the amount we actually print. So for example, if we request 100mm of filament but only getting 90mm, we are going to adjust that and compensate the Klipper to be sure we're getting proper amounts of filament in our prints. You'll want to measure around 120mm of filament from the extruder and then mark it using a marker or some tape, and then request printing 90 to 100mm of filament, and then make a note of the difference. There's a small formula you'll need to use here, then you'll have to save the value in machine.cfg. This is another procedure that's good to do a few times. Let's move on with the bed tramming. Despite having a probe for leveling, it's a very good idea to manually level the bed as well as we can, and having a probe with Klipper enables us to go through a much nicer process than ye old Creality times. To be able to use the nice process, you'll have to go through setting up the position of your bed screws as well as their sizing and step. Afterwards, it will be a very simple command that you run, and Klipper will give you the exact amount of rotation to apply to each of the screws. You'll have to go through this process a few times, but thankfully this isn't something that you do often, and it's much simpler than using a level and the paper method to get as straight a bed as you could. Now we're getting into the nits and grits. Let's have a look at the first layer squish. Possibly the most impactful part of the process. This will make sure you always get proper adhesion on the first layer and prevent spaghetti hell from coming to get you. What we're going to do here is print a few squares, and for each square we're going to live adjust the Z offset bit by bit to find the sweet spot in which the nozzle is not too close but not too far from the bed, enabling good adhesion and good squish. As always, I recommend either pausing the video and going to Ellis's website or fully following their guide on ellis3dp.com. After a few trials, I've got the result that I want, so I'll go ahead and save that new value in Klipper. You can find a lot of examples of prints going wrong and right on the website with images, so again, if you're encountering issues, go to the guide and read it in depth. Now, the most black magic of these settings is the Pressure Advance. Arguably the nicest feature you can add to an older 3D printer, Pressure Advance enables consistent printing at varying speeds. So when your printer will have very fast movement, the filament will keep up by ramping up the flow of filament leaving the nozzle as to compensate for that fast movement, enabling a line with the same width across the board regardless of your acceleration. Ellis created a new method based on a custom G-code generator for tuning this, so visiting their website is a must for this step. You'll have to input some settings and then get a G-code file ready to print. You're looking for the line with the sharpest corner with the least imperfections both in the middle as well as on the sides of the frame. Once you get a value, you can go with that and save it in Klipper, but be cautioned that this value will change for different types of filament, brands, or even age, since humidity can sometimes play a role in the quality of the filament. I'll end this very short guide here, but there's way more settings that you can tune and then retune. Following the guide in the description can get you very close to a better printing experience. You just need the patience for it. Thanks for watching.